This conference will now be recorded.
All right, this is the summary of factoring video. I wanted to do a couple of the ones we skipped over and also the big factoring one with the negative exponents at the end. So I wanted to do another perfect cube. Essentially, this is the difference of two perfect cubes. The cubed root of 8 is 2, and the cubed root of x cubed is x. The cubed root of 125 is 5 cubed. So if we're using the perfect cube pattern, remember we get a binomial and a trinomial. The first binomial part is just the 2x and the 5 with the sign of the original, so that's a minus. To get your pairs in the other group, you do 2x times 2x. Then you do 2x times 5, and then 5 times 5. So this would be 4x squared. You change signs from the original, so that would be plus 10x, and then always positive at the end, so plus 25. Now I'm going to do this other one below it as well, because I honestly couldn't remember which one we did. So this would be x to the third. This would be a 3y squared to the third, because it's got to make 6 when we multiply. And we want it to be a cube on the outside since this is perfect cubes. So this one would be x minus 3y squared. And then it would be x squared, because we do x times x. You multiply x times 3y squared, so that would be a positive 3xy squared. And then you have to do 3y squared times 3y squared. So that's 9y to the fourth. So there's that one. We did not do these factor by grouping ones, so I wanted to go through this. We could pull out a y for the first pair, so that makes that 2y minus x. We can pull out a positive 3x in the second pair, and that leaves us with 2y minus x. And since those match, that comes to the front like a GCF, and then we're left with a y plus 3x. So notice this one factors. Okay, the j, we have, again, let's try factor by grouping. We can pull out an x to the third out of the first one. So that makes that x minus 3. This leads with a positive, and those are both divisible by 9. So if we pull out a 9, that would be, I think, oh, it's bigger. We can pull out, let me see, does 27 go into both? Yes, so 27 can go into 81. So that also leaves me x minus 3. So I had to double check that one. Then this would be a matching x minus 3, and then we get x cubed plus 27. Now the point is of this problem, this very last one, is to see if you're paying attention, because that is not completely factored. This is two perfect cubes again. So we know we have this x minus 3 that came from here, but this guy is going to break into a binomial and a trinomial. It is cubed root of that is x, cubed root of this is 3, so it's going to be x, keep your sign, plus 3. And then we have x times x, which would be x squared. X times 3 is 3x. 3 times 3 is 9. Same as the original sign, opposite to the original sign, always positive. Remember SOAP. So this one, and this does not factor any further. There's no factors of 9 that are same sign because it's positive 9, and add to a negative 3. Okay, so there was this one last problem we didn't do. I did the first big factoring problem. I wanted to do one with the negative, just so you could see that. This is negative exponents. Your first step here is to combine these monomials if you can, because they don't have exponents on them. So remember, this is my plus sign. So that makes this 12, 3x plus 2 to the negative 3. And then my 4x minus 5 to the third. And then plus, and this is negative 4 times 3, so that's going to be negative 12. I usually write it in the same order as the first group, so this will be 3x plus 2 to the negative fourth, and 4x minus 5 squared. Now, when we go to pull out a GCF, obviously they have a 12 in common, so that can be pulled out to the front. And we also see that they have some common binomials. When you're trying to pick, is it pulling out a -3 or a -4, the rule is still you pick the smaller number as the exponent you pull out. -4 is actually smaller than -3 in terms of numbers. So 3x plus 2 to the -4 is what they would have in common. And then it's easier with the second group because they are both plus exponents. So it's a 3 and a 2. We're going to pull out 2 because that's the smaller exponent. That's what they have in common. And then we have to ask what would be left. So 12 divided by 12 is 1. If you have -3 and you pull out -4, you've actually pulled out what it looks like one more than you actually had. So it's hard for people to visualize this one. You're doing, let's just do it with an x. If you have x to the -3 over an x to the -4, let's say you're dividing out -4, because when we pull something out, we're dividing it out. These are both negative exponents, so if you flip-flop them, because of the negative exponent law, remember, that makes this a positive and this one a positive, it's just going to reduce to just x to the first. So that's what this does when we pull out the smaller one. It leaves us with the difference between these as a positive exponent. So I still have a 3x plus 2. I had 3 of these. I pull out 1, so I have a 4x minus 5 left. Okay, for the second group, I had a -12. I divided by 12, so that means I have a -1. And then I pulled both of these out, so I have nothing else left in that group. We need to FOIL this out. So this is 12x squared minus 15x plus 8x minus 10 minus 1. So for my final answer, I have a 12. I'm going to skip this guy for a second. I have a 4x minus 5 squared. I also have a 12x squared minus 7x, because I'm subtracting my like terms, and then minus 11. And the reason I didn't write anything for this is it's a negative exponent. It needs to move that whole binomial attached to it to the denominator. So it's all over that to the 4th. So that's how you handle it if you get negative exponents. All right, that's the end of this video.